Marty Glodoski. I'm with Sensus USA for about the last 8 or 9 years. Before that, I used to be a water guy like you guys. I was the one that went out when somebody called and had a complaint on a high bill or whatever, had to try and troubleshoot that. Got a lot of experience doing that. So I had 30 years on the municipal side before doing this. So I understand a lot of what you're doing, and I tell you what, I appreciate you for what you do. You guys should be proud of your career, your profession. It's a very good one. So, use of data logging meters. Beth Peterson was supposed to be here to help me do this, but she got kind of busy today. So I promised I would show you a picture of her so that you would know who Beth Peterson is. Make sure you let her know that we, let everybody see her. This is last year on Valentine's Day, but I'm not the one with her on Valentine's Day. I just have this picture. So, water utility's been around a long time, and the way that meters worked and the way that meters read have been around for a long time, from around 1900 till about 1999. Not a lot of change, really. The meters themselves operate on a principle where they use a mutating disc or a piston that moves back and forth. That thing on the left there is actually from 1897. That was the mechanics of a meter at the time. And the meters that we sold up till maybe about 8 years ago still work the same way. They hadn't really changed. And the problems haven't changed either. When you meter water, eventually you find out that some people are unhappy with the bill, like this person. You get a call. Usually they're pretty upset because they got something they weren't expecting. Anybody here ever had that happen? Never? Anybody got any good stories? Come on, we're on film. Well, I got plenty of them. And a lot of times, what would happen is they'd send you out from the office and tell you that, so-and-so has a high bill, and they put a couple of readings on a piece of paper and hand that to you, and you go there and you try to figure out where the water went. If you're lucky, when you get there, that meter's turning or something going on, and you can help them track down where the leak is. And 9 times out of 10, it seemed like it was always in a leaky toilet or something like that. And a lot of times it was, if they had 2 or 3 bathrooms, it was the one that they hardly ever used, like the one in the basement or something. Sometimes you could hear them, sometimes you couldn't. If they were just a small leak, you couldn't always hear them, but a lot of times they were running like really hard. Most people could hear them, but not everybody. And sometimes it was older people, and fixed income people, they'd get a high bill, you'd feel pretty bad about it. You hadn't followed it because it's been 3 months since the last time you read the meter. If you got there and the thing wasn't turning, then it was a little harder because then you had to try to help them remember what happened in the last 3 months that might have caused the high bill. Sometimes you can do that and they do remember and all is well, but sometimes they don't remember, or sometimes they know and they're not telling you. That happened a lot. They left the hose running or sprinkler going or kids were doing something or whatever. That happened a lot. But it always left us kind of in a poor position because we didn't have a lot of information to help them accept those readings, and sometimes they're like 3 months apart. But now with the newer technology meters that are coming out, these are all electronic in some cases. They measure a lot more accurate than the ones we've ever made before, by far. They last longer. The accuracy is maintained for the whole 20 years in some cases. They don't lose accuracy over time. All that's amazing stuff. But what to me is one of the most amazing things is they all have history, they all have memory inside the register now, and you can get that out. You don't have to have a big fancy radio system to do it either. It's built into the meter. Even a guy with 100 meters in his town can get this out and use it. So the big ones and the small ones both have it. So there's Beth again, and that's kind of how you do it. You can walk up, kind of like the guy that works on your car, where you drive into the car shop now, they'll plug something into your car like a computer, and they'll get out all the codes and all the information of what went on in your car for the last couple months. It's like that with a meter now. You can go with a laptop outside, you can do it from the touchpad, you don't even need an appointment. And so you can get this information out without having to trouble anybody. So it's pretty powerful. The software is free, and a little device that you use to connect to your laptop, that's very inexpensive. So I'm going to show you what some of these things look like. These are the logs that come out of the meters. And I'm just going to give you some examples, and I'm going to try real hard not to bore you to death because this is a lot of numbers and charts and things, but they're pretty interesting. So this is a typical 3-bedroom ranch house, 2 adults, 2 kids. Oh, Dave, how do I get your pointer up here? Go, Dave. Give me just a second here.
Can't leave you alone for a minute.
Hey, how do you get your pointer? How do you get your mouse to work?
Here's a mouse.
Oh, use a mouse. There we go. So this is a house in central Wisconsin. It's just a typical ranch house. And what you see here are hourly consumption data. This is 34.3 gallons went through the meter between 7 a.m. and 8 a.m. 2.9 or 0.29. All night long you see all these zeros. That's what you like to see. That's nothing's leaking in that house. That's no toilets, no anything, nothing's using water. This is probably a flush. That's probably a flush. 9 o'clock, 9 p.m. there's a sprinkler on a timer at this house where the irrigation comes on, and you can see it every day. It comes on around the same time. So during the day, you see where people are using water, washing clothes and things. But at night, you see these zeros. That's really good. These meters are so accurate. That's 0.05 is like a thimble of water in an hour's time, and they pick that up. The old brass ones never ever could do that. Even new ones couldn't do that. So that's a good house. That's what you like to see. Sometimes you'll see this negative 0.04 or negative 0.01. What that is pressure fluctuation in the main outside. It's moving water just slightly inside the meter, and it's picking that up too. So that's kind of keep that in mind, because that's what you like to see. That's a good installation. There's no leaks there. Whatever they're using in the house is getting metered by the meter. This is a different case. This is Angry Betty. This turns out to be a house where there's an older woman that lives here. She's a widow, and she goes away for the whole winter time. And her daughter, Betty, is kind of keeping an eye on the place for her. She stops by her once in a while just to see that nothing froze up. And after a couple months, the water bill showed up, and it's $200. And Betty's kind of upset because the house has been empty for 3 months. How could it be $200, you know? And so she's just demanding that there must be something wrong with the meter. And so we go outside and we pull the data from the meter, and you can see here every hour 10 gallons. And it just keeps going like that for weeks at a time, 10 gallons all the time. And so we called up Betty and said, you know, somebody needs to go and check on it because there's definitely something leaking. It's not a big leak, but it's making the bill add up all those tens. It's a lot of gallons. And so she had a plumber come over and fix what he thought was a leak. And then she asked us to come back and pull the data out of the meter again just to make sure something else wasn't still running. And so this is that second one. This is that second data pull. And so you can see where all the leak was. This is all through March about a year ago. And then you can see all the way in April. And you can see why this was a $200 bill, right? But come April, should be coming up here pretty soon. This should use the page up, I guess. Not hard to see where he fixed it. That's where the plumber fixed it. You can see it's between, 11 and 12 on the 14th, and after that, zeros. And so that's definitely pretty good information to be able to show Betty, why the $200 bill. They used the water, it went through the meter, no question about it. You can also see a lot of days around 9 a.m. sometimes, or 6 a.m., where Betty stops by to check on the house because she uses the bathroom. So it's just amazing information to be able to have that. You can send these, you can email these reports to the owner, to give them some documentation on what was going on. It comes out in a graph. The graph is kind of handy for some folks. They like to see that. So the graph looks like this. Oh, I'm sorry, that's not the graph. I will show you that later. So after you show her what the bill was, why it happened, all that, it's really nice to be able to go back there and explain that to her. So it was customer service. This one is a little town, actually in Minnesota here. They put in a bunch of new meters, and not too long after they put them in, the first bill comes out, and this is a landlord that owns this. This lady owns a house, and she said, nobody's living there. House is empty, there's nobody there. Check for yourself, have your guys drive by and see, go inside, there's nobody in the house. And so they do, they go outside, they look in the windows, they get inside, there's nobody in the house. The meter's not turning. You don't know why the bill is, expensive. Why was the bill $200? And in the past, you would probably have to say, well, I guess we got something wrong. Maybe we'll have to adjust your bill because you don't have any reason why the bill is high. But now we can pull this data out, and we did that, and the landlord's actually there while we're doing it, and she didn't realize we could do this. But every night around 10 a.m., the meter starts turning, around 9 a.m. actually, p.m. Now this is in cubic feet, so this is actually a fair amount of water. You multiply that times 7.48 per each hour. That's a couple thousand gallons each night, every night. And guess what? She suddenly remembers that she let somebody use her house, her boyfriend, who was going there at night filling up tanks. He's a brick mason. And he's filling up his water tanks at night at her house. So, her deal was, I guess I'll have to pay the bill. I guess you will, Now you got all this proof. This is awesome stuff to be able to do that, and it's just night and day. It's hard to dispute that. And there it goes for weeks at a time, the same thing. But during the day when, the city comes by, the house is empty.
These boyfriend's working.
So she was angry, but she had to pay the bill. This is another landlord. This one was actually kind of happy that we were able to do this. Uh-oh. got some of my links messed up, sorry guys. Wonder how I can... What this one turned out to be, I'll just tell you the story. It's a townhouse where there's two sides. It's a side by side, and there's one service that goes to the building, one water lateral, 1 meter. It feeds 2 families. It's a house that's next to each other, like a duplex, only next to each other. And on one side of the house is an older couple that's really careful about the water that they use. On the other side of the house is another couple who are younger and they're not as frugal, and they're always causing problems for the older couple. And the young couple got into an argument with the landlord and tried to get her back. They turned the garden hose on and left it on for the weekend in the back of the house, and then left and then moved out. And the landlord didn't know how to prove that they did that. Well, we got the log that shows over that weekend there was like 6,000 gallons run a day out the back door. She was able to take that to the city attorney, and the city attorney said, yeah, you can get that from those tenants. And so she collected on that because of the data log that was pulled out of the meter. Lots of good stories. People send me these all the time. This one guy sent me this morning. I mean, they like it so much, they know I collect these, and so they keep sending me these different stories. A lot of times this is secondhand information, but you know, I'm telling you the way I hear it. So this one is somebody that this town was sure was probably tampering with his meter, had been for a long time. They suspected him of it, but they could never catch him. So now they put this new electronic meter in there, and they found out, sure enough, when they left there, the thing was in right and measuring forward, but they now measure backwards just as accurately as they do forward. And you can tell for weeks this thing is measuring negative numbers here, hour by hour. And then just this week, they called the guy up and said, you know, we want to come in and check on your meter because something's wrong. And read your meter for the water bill, and you actually used negative gallons. He forgot to turn it around, so when they called him, he suddenly remembered. And then you can see down here where all of a sudden at a certain date and time here this week, the thing all of a sudden by itself just starts measuring forward again. All by itself. These are all the negative ones. This is cubic feet also, by the way.
These are software that changes.
Yeah. So right about here is where he turned it back around again. These things also know there's a tamper alert inside the meter for when there's an empty pipe. So when somebody does take it out of service for any reason, it records when that happened. And it's like an alarm too. When you put it backwards, it's a backflow alarm. It gives you that. So this is a lot. So this guy actually had to go face the police department, and they kind of started asking him questions. He ended up paying a municipal fine. So he paid like $600 today for this. So this is a pretty recent one. Want to see more?
Sure.
This is a little town, very little town. There's about 300 meters in this town, and this is a small house, an old house, where there's renters living, and they had a big leak, went on for a long time. They didn't pay the bill. The city came and tried to collect from them. So you can see here every hour this was running about 7 gallons an hour. Which, by the way, if you divide that 7 gallons an hour out into 60 minutes, that's like 0.1 gallon a minute. That's just barely a drip, but yeah, look what it does. I mean, it really adds up. It really makes the bill pretty big. Then they started using a lot of water for a while, and then eventually they got kicked out. They got evicted, and the landlord asked the city to turn the water off. And the city guy came at the end of the day to turn it off, right before he went home. This is only like a month ago, and you know, there's like a big snow bank and the bell box was all frozen and crooked. He got the key on it and he thought he turned it off, but he wasn't sure, and so they pulled this out just to see. And you can see he did get it off, and you can see exactly what time he did it. Right there, on the 8th, right between 6 and 7 p.m., water's off. So without having to go in the house, we were able to tell from outside that that was taken care of. So this is actually, there's on big meters too, there's a lot of good stories on these things. This one's from a school superintendent. I tried to find a picture like a report card. This guy, he was really interested in water conservation, and if you ever put a data logging meter in a school, you're going to be surprised at how much water that school uses when there's no kids there. Day and night, weekends, Christmas vacation, that meter's turning in a school. That's just amazing, especially on an older one. Well, this guy had spent a bunch of money to try to put in water conservation fixtures, low flow toilets and all that. He wanted me to pull the data to see how well he did. Well, I think he did really good. So this is after. And so you can see when the kids get there, they all show up around this time, you know, like 6 a.m. First people show up. Uses a lot of water in the daytime during lunch. And then at night, nothing. So that's a good story. So he's a happy guy. He can show that to the school board. Said, yeah, we spent some money, but we're saving a lot of money. We're saving water. It's a good thing. There's some that don't have such a happy story. This is a guy that owns a hotel with 100 rooms. It's an older hotel. Uh-oh. And you know, I should try and find out how I can run this file, because this is a good one. Can I plug my laptop into this thing? This won't take long. So in this hotel, they had a 4-inch turbo meter for years. So it's a 100-room hotel. It's got a banquet center, a restaurant, swimming pool. It's got a sauna, and this 4-inch turbo would measure just about 600,000 gallons a quarter every quarter. So that's a pretty good customer. So they put in one of these more accurate meters, and the first time they go to read the meter and send out a bill, it's 1.5 million gallons. Just a huge amount. And of course the guy, the water superintendent, he calls up right away. He wants me to come talk to the mayor, because the mayor's related to the guy that owns the hotel. And the next thing you know, we're out in a snowbank in the middle of this town pulling out this data. But I'll show you this is worth seeing. This is pretty amazing. So where's my little file here?
That means you put the turbo meter back in?
Yeah. These are all the ones people sent me from all over the place. And this one that I'm looking for is right here. Instead of seeing zeros at night, this thing never goes below 400 gallons an hour. Look at that. I'm sure with the old meter that was zeros. you know, but the new one now can pick up that low flow. And you wouldn't think 400 gallons an hour is really a low flow, but that's really 6.5 gallons a minute, which is about a garden hose half open. You know, it's not a lot of water. And it turned out to be a handful of leaky toilets, like about 6 of them. You know, in the daytime it would use more, but it would never drop below 400. Those leaky toilets are leaking all the time. And just think of what that adds up, that the old one never measured, the new one does. There's almost 1 million gallons in a quarter. So without this, it's pretty tough to justify that 1.5 million gallon bill. And the way they did it is they said to the guy, look, you know, we know that it's been leaking that way for a long time. We know that we haven't been billing you for all the water that you've been using. We're not going to back bill you. You know, we'll forgive the stuff that we didn't bill you for before, but from now on we're going to have to do it right. And so he had to get the plumber in and fix the problems and take care of it. I'm going to switch this back. Right here. It's the end of the day, so we're a little technology challenged here. You just went through that. So you're going to tell Beth to show the picture? Yeah. Upside down. Up one. 13. We're going to get this yet. I hope this one works. This is another school. This is a middle school. Oh, where's the mouse now? There you go. This one is a little more concerning. In that this is a middle school, and what we see is that every day around 5 a.m. there's a fair amount of reverse flow in this building. Remember, it's pretty serious in any building, but in a school you really should be concerned about it. That's 7.258 gallons per minute at 5 a.m. And there it happens again at the same time for 2 hours. And as you go here, it's even more. That's a lot of backflow. I mean, that's not what you want to see. And what this turned out to be, now remember, if we didn't have these data logs, you would never know that. You read it once a month or once a quarter, you would not ever figure that out. You'd never see it unless you got this. What that turned out to be is this school is connected to a part of the distribution main where there's low pressure, like 45 pounds. It's enough for a house, but it's really not enough for a building like a school. And so what they did is they installed a pump that pumps water from the city system into a pressure tank, and then the school runs off of that pressure tank like a well system. So it's running off of 70 psi, but there's a check valve, and that's leaking, and that's the leak. It's actually doing it all the time. It's just that over on the left, you can see during the low flow periods at night is when you can see it. But it's going on all the time. You just don't know it when there's a lot of water going through there. So they fixed the valve, they solved the problem, that took care of it. You got time for one more? it or not, there's a little town over by Green Bay called Leanr. And there's a cheese factory in Leanr. And I got to go there. I get to go to a lot of interesting places. I went to a turkey processing plant up in Melrose. If you've ever been there, that's where the stop. That's where they bring in live turkeys and send out frozen ones. And that's the in-between part that I got to see. This is a cheese factory in Leanr, pretty new and very, very modern. Use a pretty good amount of water. They had something going on here, and their meter picks it up. You know, that's a good customer, you know, over thousands of gallons a day. It's about half the town's consumption goes through this one meter. I highlighted these in yellow so I could find them. That's a serious backflow. That's like 50 gallons for a full hour that the thing was running backwards. That's sending plant water back out to the city main. This had something to do with their processing where they clean up the plant every once in a while and they use high pressure pumps or washers or something to do it. We found it, they tracked it down, they could see exactly what time that happened, on what day. They could look back and they could see in their logs what they were doing, and they tracked down the problem so that they wouldn't have it happen again. Definitely not something you ever want to see in your cheese, is backflow, flat flow water. So you can get that out. That data's in the meters. You don't have to have a fancy radio system. It's in there. The small ones store 45 days worth if you save it hourly. If you want to get more time, you can save a reading every 2 hours and then you can get 90 days worth. If you want to save every day, like one reading a day, you can actually get more than a year's worth. When you do that, though, you don't see all the small things, all the leaks, if you make that too big of a span. So one every hour, one every 2 hours is pretty good. If you're reading meters right now, once a quarter or once a month, you're not getting any of that information. If you're reading them to the 1,000 gallon read or the 100 cubic feet read, you definitely won't be getting all that information. So that's what AMR is. That's what you're getting when you read them once a month or once a quarter. That means automatic meter reading where you're going by and reading them from the street or house to house. That's pretty good. But if you could get all that information back to your office and then had software to look for those problems automatically so you wouldn't have to go and look through all these rows and rows of numbers, that's even better. And there is that system today that's called AMI. You hear that term AMI, that means Advanced Metering Infrastructure. And what that is where they come by and put an antenna on your water tower, and now all those meters are talking to the antenna, sending that information to your base station back to City Hall, and now you get all that stuff back on your desktop. That's what AMI is. It takes a little bit of extra parts to make that work. But today, that's what everybody's asking us for. In my 2 states, I've got probably over 30 of those systems right now up and running that do AMI. If you're a town of maybe 3,000 meters or bigger, that's what you're interested in. That's what people are calling me about. We do a lot of it. Around here, Melrose is putting that in right now. North St. Paul, Crystal, Minnesota has had that for a couple of years. Little St. Anthony was the first one in this area to get it about 4 or 5 years ago. College towns like it a lot. Menominee, Wisconsin, put it in. This town doesn't do it yet, but they're considering it. I put this up here because I got this in the mail today, an email. Nationwide, more than 1 trillion gallons of water leak from U.S. homes each year. Man, that's huge. I mean, that's just an unbelievable number. A lot of it's in these toilet leaks and this stuff. I mean, that water went through the meter, never got used. All that was treated by you guys, right? You spend a lot of money pumping it and treating it. And you're spending more money on it when you're trying to clean it up before you put it back into the sewer plant. So It's no wonder that today there's a big thing about water conservation, water use, cross connections, vulnerability assessments, tampering, all those things are important things. That's what AMI does. That's what this vision is called. It's called a water smart grid. Sensus calls it AquaSense, but smart grid for water is kind of the industry term. So today, in bigger systems, you can tie in all your water meter information. These little things here are little devices that go on gate valves and listen for leaks, like if you had a broken water main. You can tie all that into one system. And you can add in the SCADA stuff from your lift stations, information from your wastewater treatment plant, water quality information. There's sensors out there now that will be able to measure disinfection levels, chlorine levels, pressure sensors on meters. If you know about the electric guys, they've had this for a while. If there's a power outage, they can tell on a map which part of their system there's a power outage, because the meters all send out something there's power out. Well, we do the same thing with water meters. We have little pressure sensors on there, and they tell you, okay, something happened. So you can tell right away when there's a problem. Soon to be little gate valves or little ball valves on a water meter, so you can disconnect people for different reasons. Sometimes for not paying. So that's the smart grid for water. That's the vision of it. That's what a lot of the systems are putting in today. We're putting in USA Sensus, we're putting in over 300 of them right now for water utilities. There's a lot more for electric utilities. It starts with that data, the data logging, all that stuff. This just automates it. So any questions at all? What do you got? Come on. You want to send me some logs when you get them? This is my email address, phone number. If you're ever interested in doing that, I'm the guy that comes out and helps you do it. I set it up for you on your laptop, help you pull the data, train you how to use it, teach you how to interpret it.
Yeah, it's a big one.
I was wondering, what year are they going to get rid of the lead? They're going to all the plastic meters. Do you know what year?
2014,
14.
next year. Yep.
Thank you.
Ours, we're kind of ahead of the curve a little bit. The ones that I showed you back here at the beginning. These had lead. I don't know how much you know about it, but these are Waterworks brass. It's 8535 is what that's called, that alloy. So that's 85% copper, 5% zinc, tin, and lead. And the lead part is the part that's concerning to people. They came out some years ago with the lead and copper rule. They said we have to limit the amount of lead that's being dissolved by water. And then now it's getting stricter and stricter. Now what you're asking about is they're going lead free. So that 5% lead is no good. Rather than try to fight that, because there's other things in here too, right? Cadmium and zinc and other things that are going to be regulated probably in the future. Even copper is dangerous if you get too much of it. Sensus just decided as a company that we would go away from lead altogether. So this one, actually, this measuring tube in here is 30% glass. There's no lead at all. This one is ductile iron with epoxy coating on it. So we don't make very much brass stuff anymore.
I've been away from the industry for a while. Does that have a register on it that you can manually read, or is it just basically going to be blank?
No, it's got a little cover. There's
So you can.
there's a LED in there, LCD. Yep.
See, not a question here, but a comment. What I found changing these out too, that gallon per minute is real handy when you're downsizing meters.
Yeah.
I've been able to go from some compounds down to, say, a 1-inch high per outlet.
Yeah, exactly. Yeah.
And see exactly what you're getting gallon per minute.
You never knew before. You were always kind of guessing on whether or not you had the right meter in there because you had a monthly reading. And the ones I showed you, those data logs, at the top of that page, it showed an average flow, peak flow. All that is important for when you're sizing the meters. So it's good information. The more you do it, the more interesting it is, and I just think it's great, because I can't tell you how many times I was getting yelled at by somebody, and I really didn't have any answers for them. They always thought I was making stuff up, you know? But now you have awesome information. You can give them a report, you can show them a graph. It's just way better.
Any other questions? I like the one about 1 in the morning, 0.1 or whatever. I'm thinking that's a glass of water and 2 aspirins, so that's pretty cool. Well, thank you, Marty. Let's give him a round of applause, please.